Mm.
Good morning all. So today's topic is going to be on horn antenna. So before going into the details of horn antenna, I would like to brief about the definitions of antenna first. So antenna is a metallic structure that will receive or transmit electromagnetic wave into space. So these antennas are coming in different sizes, shapes, etc. depending upon the applications. So one such antenna is called horn antenna because it is in the shape of a horn. So this is an example of a horn antenna. So horn antenna is nothing but a metallic structure that flashes out into the space in different angles and different directions. So depending upon how it is flaring out, there are actually three types of horn antennas. One is, this is a sectoral horn antenna. So sectoral horn antenna can be either E sectorial or H sectorial. So E sectorial means if the flaring is along the direction of E plane, then it is called E sectorial. That is in the rectangular waveguide. If it is on the broader, if it is flaring out along the broader side of the waveguide, then it is called E sectorial. If it is along the H, that is magnetic field of the electromagnetic wave, then it is called as H sectorial. That means it will be along the height of the electromagnetic wave. If the flaring out is on both directions, in case of x and y directions or width and height, flaring is on both directions, then it is called pyramidal horn antenna. There is another type of horn antenna is also available. Suppose if the waveguide is a circular waveguide and the horn is flaring out in all the direction in a circular fashion, then it is also called as conical horn antenna because the waveguide structure is a circular one. As a result of flaring out, you will get a structure called cone. So the antenna is also called as conical antenna. So there are a few advantages of this horn antenna. One is its moderate directivity and the other one is its wide bandwidth because operating frequency of a horn antenna starts from 300 megahertz to 3 gigahertz. So throughout the entire frequency it has moderate directivity. So you can say it has a very good directivity. Also it has a wide bandwidth and because of all these reasons it finds wide applications also in the case of in our day-to-day life. So you must have seen very small antennas located in our rooftops for seeing TV. And we should have also seen a very big parabolic reflector which is used to receive and transmit signals to and from the earth station to the satellite and satellite to the earth station. So there are different types. So this horn antenna also can be used in all these cases. So it can be used as a feed antenna. So when it is used as a feed antenna, the output from the horn antenna will be given to the reflector of a very big parabolic reflector, directing the entire signal towards the reflector so as to get maximum efficiency. That is called feed antenna. So horn antenna can be used as a feed antenna. Then it can be also used in radars because of its wide bandwidth, also the moderate directivity. Then the third application is again in satellite. As I have already mentioned, it can be also used in satellite communication because in satellite communication you need communication from or transmission from base station to satellite, similarly from satellite to base stations. So in both these cases, as we know, the frequency range for satellite communication is very large, and since the horn antenna can be used between 300 megahertz to 30 gigahertz, it can be very well used in satellite communication also. Another important application of horn antenna is used as a referral antenna in case of measurements, or you can also call it as calibrating antenna. It can be used as a calibrating antenna. Suppose you are going for a measurement of an unknown antenna. So you want to measure the input impedance of an unknown antenna or directivity of the unknown antenna or mainly gain of an unknown antenna. Then this horn antenna can be used as a referral antenna, a basic antenna whose parameters are known already because they can be easily calculated from these parameters. So A is the width of the antenna, and theta h the azimuth angle along the h direction, A aperture area of the antenna. So if these parameters are known, you can easily calculate the gain of the horn antenna. So it's a simple design. The main advantage of horn antenna is because of its simple structure and design. You can easily calculate the gain. So gain of the horn antenna can be easily calculated. So gain of any unknown antenna can be easily calculated using this as a referral antenna. So these are the main applications of horn antenna. So this horn antenna, as usual, for like any other antenna, it can be used also as a transmitter and a receiver. Both as a transmitter and receiver it can be used. So when it is used as a transmitter, it actually launches the electromagnetic wave into the space, or you can say the alternating current coming from the waveguide or a coaxial cable is converted into an electromagnetic wave when it transfers its energy into the space. Similarly, when it is used as a receiver antenna or when it is capturing the electromagnetic power, it will be converting the electromagnetic wave signal into an alternating current so as to process it further, usually amplifier. So amplifier will be the next stage in the case of a receiver. So this is another added advantage. The same horn antenna can be used both as a transmitter as well as a receiver antenna. So I hope this will give you a brief introduction about horn antenna. Thank you for your patient listening.